Hello everyone, welcome back to rkphysicsshiksha. In this video, we are going to discuss the projectile motion on an inclined plane. In that one, we have the first condition where you project an object up the inclined plane from point A with an initial velocity u at an angle alpha with the inclined plane. In this, what we are supposed to calculate is time of flight, range of the projectile, and also velocity at the point of striking the ground. So for that, if you observe the diagram, if you are having an object projected up the inclined plane making an angle alpha with the inclination, sorry, my mistake, it is made, alpha is the angle made by the projectile with the inclined plane, and theta is the angle of inclination of the inclined plane. So what we are supposed to calculate is we are supposed to calculate the distance, that is horizontal distance up the inclined plane is how much, which is AB value, and the time taken for the particle to reach the whole distance of r from point A to point B, and the velocity with which it will strike the ground, or also angle with which it will be striking the ground. For all this, we have to take the components as well. We know very clearly if you are projecting with an initial velocity u, you have a horizontal component ux and vertical component uy. So what will be this horizontal component of initial velocity ux is equal to, ux can be written as u sine u cos alpha. We write it as u cos alpha, and uy, the vertical component of initial velocity, is u sine alpha. And at the point of striking the ground, if we observe, beta is the angle, so Vx, the horizontal component of velocity, will be Vx is equal to V cos beta, and the vertical component of velocity Vy is equal to V sin beta. Also, we have the acceleration due to gravity, where it will have both the components, where it will have acceleration due to gravity as it will have a simple way, acceleration is there along both x coordinate system as well as y coordinate, means it will have both the acceleration. So in that case, it will be horizontal component will be ax is equal to minus g sin theta, and vertical component ay will be equal to minus g cos theta. Why we have taken theta here is because if you observe, if at any point if you draw the parallel line to the base, and if you draw parallel line to the base, if you draw the parallel line to the base and parallel line to the inclination, this angle here will become theta. So if you draw one line here which is along the direction of the g value, its perpendicular components will be having an angle theta here again. So this component will become g cos theta, and this component here will become g sin theta, and they are acting along the negative coordinates of the x-axis and y-axis. So we take it as negative side, so it will be x here, y here, positive x, positive y. So the negative direction is what they are acting, so we take it negative, or they'll be always acting downward, so we take them negative. Next, what do we have here along the x-axis direction? For example, if we observe from the points from A to B, for the journey from A to B, what do we have here is, we have sy, the vertical component of the displacement will be always 0, and you have sx, which is equal to range of the projectile. And for the same, if to calculate the time of flight, for calculation of time of flight, we use the equation sy is equal to uy into t plus half into ay into t square, where sy will be equal to 0 for the total displacement of A to B, and uy is equal to the vertical component of initial velocity, which is u sine alpha, and ay is equal to, we have it as minus g cos theta, and time of flight we have taken it as capital T. So substituting all these values in the above equation, I get 0 is equal to u sine alpha into capital T minus half into g into half into g cos theta into t square. So from which I can write half g cos theta into t square is equal to u sine alpha into capital T, from which capital T square gets cancelled out, and I get time of flight as time of flight capital T is equal to 2u sine alpha divided by g cos theta. This is the time of flight of the projectile. And now if we are supposed to calculate the range of the projectile, again using the relation, using for the range of projectile range calculation, what we'll use is using Sx is equal to ux into t plus half into ax into t square. Here again Sx is the range, horizontal displacement of the inclined plane, and ux is the value of initial velocity along up the inclined plane, which is u cos alpha, and ax is the acceleration which is minus g sine theta, and time of flight is t small t, which is equal to time of flight t, which is 2u sine alpha by g cos theta. Substituting these values in the above equation, I get r is equal to u cos alpha, r is equal to ux is u cos alpha into time of flight is 2u sine alpha divided by, we get it as g cos theta minus half into g sine theta into 4u square sine square alpha divided by g square cos square theta. So from which I can cancel 2 here, 2, so g and square gets cancelled out. So what we will remain here is with the, I can write it as we have it as u cos alpha, means you can just write it as r is equal to u square into 2 sine alpha cos alpha divided by g cos theta minus, we can write it as 2u square sine square alpha sine theta divided by g cos square theta, from which further on taking the value of u square by g cos square theta. So what will I get is u square by g cos theta, means anyway g cos square theta. If I take common out, here we have only g cos theta, so for this equation you multiply and divide it with cos theta, so it will become cos square theta, and you have cos theta here again. So from which and here we can replace 2 sine alpha cos alpha is as 2 sine 2 alpha. So in that case, if I take it common, I get sine 2 alpha into cos theta minus sine theta into 2 sine square alpha. Why? Because here, since I just have 2 sine alpha cos alpha as since 2 sine alpha cos alpha is equal to sine 2 alpha, and if further for simplification if I use, I will get r is equal to u square by g cos square theta into sine 2 alpha into cos theta minus, I can write sine theta into 2 sine square alpha can be written as 1 minus cos 2 alpha, 1 minus cos 2 alpha, and further range r will be equal to u square g cos square theta into sine 2 alpha cos theta minus sine theta plus cos 2 alpha sine theta. See here this relation, which is for sine square 2 sine square t 2 sine square alpha, you can even write it using trigonometric ratio. That directly I am taking the relation here because again it will become lengthy. So in this case I can rewrite the equation as u square by g cos square theta into sine 2 alpha cos theta plus cos 2 alpha sine theta minus sine theta. I just rewrote this equation, and if you observe here, this whole portion of the equation is in the form of sine A cos B plus cos A sin B. So using that relation we can rewrite the equation of range as range R is equal to u square by g cos square theta into sine 2 alpha plus theta minus sin theta, where sine, this is in the form of what, sin A cos B plus cos A sin B, which is equal to sin A plus B. So that is what we have done here. And now this is the equation for the range. This is the equation for the range. Maximum range, if you have to calculate for maximum range, what is the condition for maximum range? So if we have to calculate the maximum range here, and what is the angle alpha value for which the range is maximum, what we need is this value of sine 2 alpha plus sine of 2 alpha plus theta should be equal to maximum, which is 1, for the calculation of the angle of projection, which is alpha value, for which the projectile will have maximum range will be alpha 2 alpha sine of 2 alpha plus theta not should be theta should be equal to maximum, that is 1. That means 2 alpha plus theta should be equal to sine inverse of 1 is pi by 2. So further on simplification, what will I get here is I get alpha value as pi by 2, means I'll get 2 alpha is equal to pi by 2 minus theta, and alpha is equal to pi by 4 minus theta by 2. I'm taking this value as alpha. R maximum, if I'll get it as R maximum is equal to u square by g cos square theta into sine of, in the place of alpha I substitute the value 2 into pi by 4 minus theta by 2 plus theta minus sine theta. On simplifying this, what I'll get is R maximum is equal to sine of 2 pi by 4 minus 2 theta by 2 can be written as 2 ones 2 2s and 2 gets cancelled. That will be sine of 90 minus theta. You can write as sine 90 minus that is pi by 2 minus theta. You can even take it as sine 90 minus theta, in the sense it will be, we can write it as so sine 2 theta, in the sense we'll get sine of 90 minus theta plus theta. If you replace it, so we'll get it like this. So it will be u square by g cos square theta into sine of 2 pi by 4 minus 2 theta by 2 plus theta minus sine theta. So in this case 2 here and 2 on, so minus theta plus theta will get cancelled anyway. So what will I remain is with sine 90 is 1, so it will be u square by g cos square theta into sine 90 is 1, so I'm directly writing it as 1 minus sine theta. So we have equation of maximum range as so much. This is the equation of maximum range of the projectile, which is u square g cos square theta into 1 minus sin theta, or you can even write it in another format as there are different ways that you can write, because you can replace cos square theta as 1 minus sin square theta, and taking a square minus b square relation, there again you can replace its value, and you can rewrite it also as, if we will discuss that also, you can rewrite it as r maximum is equal to u square into 1 minus sin theta divided by g into 1 minus sin square theta. If I have to write it 1 square minus sin square theta, if I write this equation, the denominator, it will become a square minus b square. So that we r maximum is equal to u square into 1 minus sin theta divided by g into 1 plus sin theta into 1 minus sin theta. So you get 1 minus sin theta, 1 minus sin theta cancelled out, and what we will remain is, with r maximum value is equal to u square by g into 1 plus sin theta. This is also one more way of representation of the range. This is about the range. This is the maximum range and the range of the projectile. Now we are going to discuss about the velocity at the point B. What will be the velocity at the point B? Velocity at point B. What is this point B here? The point where it will strike the ground. So for that, we need the x component of velocity and we need the y component of velocity. Usually the y component of velocity, the accelerations, the ay value used to be remaining constant in all the projectile cases, but it is up the inclined plane, so you have the value of ax also changing, or ax also there is a value, and ay also there is a value that we have already known, which is ax is equal to, we have it as minus g sin theta, and ay value we have it as minus g cos theta, and also we have vx value, we wrote it as vx is equal to v cos beta, and vy is equal to v sin beta. So as the acceleration is changing, the final velocities at this point of striking the ground also will change. So for that, for the x component of velocity, using Vx is equal to ux plus ax into t. So here, what are the values here? Vx is equal to, we know it as v cos beta, and ux is equal to, you know it as u cos alpha, and we know ax value as, ax is equal to, we know it as minus g sin theta, and time of flight is capital T, which is time of flight T is equal to, total time is nothing other than time of flight, which is equal to 2u sin alpha by g cos theta. So on substituting all these values, what I get is v cos beta is equal to u cos alpha minus g sin theta into 2u sin alpha by g cos theta. This is the equation we will get here. On simplification, what we will get is v cos beta, which is the horizontal component of velocity, which is v cos, not theta, v cos beta is equal to u cos alpha into, we can take here u cos alpha into, or u cos alpha minus g into, we'll rewrite it like this, g into sin theta by cos theta, g gets cancelled here, and further we can make it as tan theta, and we can take it as 2u sin alpha, and if you multiply and divide it here with the cos alpha, it will be cos alpha into cos alpha. So now I can take u cos alpha common out. So what will I get is v cos beta is equal to u cos alpha if I take common out, I'll remain with 1. Oh, sorry, we will not have G here, it is getting cancelled. G gets cancelled out. 1 minus, I'll remain with tan theta is there, and cos alpha is taken out, so it will become tan alpha here. So it will be 2 times of tan alpha into tan theta, because sin alpha by cos alpha is tan alpha, and tan theta we already have, so this cos alpha is taken out, and u also is taken out as common. So this is the Vx value at the point of striking the ground. And similarly, Vy value. So for calculation of Vy, using Vy is equal to, we have it as Uy plus Ay into T, where again the values are Vy is along the negative direction of the motion, or if you take it Vy is or if we have considered that x-axis, y-axis, and it is along the negative y-axis, so just take it as Vy is equal to minus V sine beta here in this case, and Uy we know it is Uy is equal to U sine alpha, and we know Ay is equal to minus G cos theta. And time of flight we know very clearly already, time of flight is equal to 2u sine alpha by we get it as G cos theta. So on substituting these values, minus V sine beta is equal to u sine alpha plus plus it will be minus u sine alpha minus G cos theta into 2u sine alpha by G cos theta. So on this substitute, simplifying this one, this and this here, G cos theta gets cancelled. So what we will remain here is with we will remain with V sine beta is equal to minus V sine beta is equal to u sine alpha minus 2u sine alpha. So minus and plus here, so it will be minus V sine beta is equal to minus u sine alpha. So minus will be plus, so it will be V sine beta is equal to u sine alpha. V sine beta is equal to u sine alpha. So this is the values of the values of the x component of velocity as well as y components of velocity. So V sine beta we have, because and at the point of striking the ground, what will be the angle at point of striking the ground? The angle will be how much? So the angle at striking the ground is, let this be equation number 2, and you take this as where is this equation 1, the Vx value, this as equation number 1. So in that case, equation 2 divided by equation 1, what will I get is V sine beta by V cos beta is equal to u sine alpha divided by, you have it as u cos alpha into, we have it as 1 minus 2 tan alpha tan theta. So here what I'll get is V and V gets cancelled, U and U gets cancelled. So tan beta, sin beta by cos beta is tan beta. So tan beta is equal to tan alpha, sin alpha by cos alpha is tan alpha divided by 1 minus 2 tan alpha tan theta. So you get the angle with which it will strike the ground in terms of alpha and theta. Hope you understood. It is a little lengthy one, but please remember the components, and at any point you can easily calculate the values that are necessarily needed. So very simple it is. So please understand, and if you have any doubts, please do comment. And for some more such videos, please do like, share, comment and subscribe our channel.